Measure airflow CFM with the HVAC Temp-Rise formula by getting a steady-state heater and blower current reading right when both are running to ensure accurate temperature delta and airflow calculation. Start by confirming the system is at steady operation. Run the blower and heating element until the supply air temperature stops climbing for at least 30 seconds. Because transient thermal lag skews the delta T used in the formula, then record amperage immediately so you capture the operating current that corresponds to that steady airflow. Use the manufacturer's blower curve or a calibrated motor nameplate chart to translate measured amperage into motor power or motor speed if you cannot directly measure fan RPM. Remember that voltage sag, pulley wear on belt drives, and dirty blower wheels all change the current to CFM relationship, so correct for those. Measure supply and return duct temperatures at least 6 duct widths downstream of any transition using probe thermometers pressed fully into the airstream. Average several readings and compute the temperature rise as supply minus return in degrees Fahrenheit. Convert the heater input power from measured amperage multiplied by measured voltage and correct for power factor when using alternating current, then apply the standard Temp-Rise formula. CFM equals heater watts divided by 120. 120 is the product of specific heat of air and pounds per cubic foot, expressed in imperial units, divided by the temperature rise. If your heater is gas, use the combustion heat input after subtracting pilot and vent losses, and use the burner efficiency. For electric heat strips, subtract any auxiliary loads not contributing to space heat, and for heat pumps in resistance backup mode, combine compressor and strip contributions carefully so you do not double count wattage. Record amperage quickly but safely. Use a clamp meter on the hottest stable conductor. Note whether the reading is root mean square and log voltage to adjust watts. Repeat the measurement 3 times at 1-minute intervals, and use the median to avoid outliers from thermostat cycling. Finally, document ambient conditions, duct leakage indications, and filter condition because CFM calculated from Temp-Rise assumes closed system mass flow and clean heat transfer surfaces. If any of those are off, apply a correction factor or run a direct airflow measurement for verification. One of the top 3 mistakes is reading amperage during transient startup, which produces incorrect airflow CFM and Temp-Rise calculations. Fix this by waiting for steady state and taking 3 time samples, then using the median. One of the top 3 issues is using nameplate current without measuring real-time voltage and power factor, causing heater wattage miscalculation. Fix this by measuring both amperage and voltage and applying power factor or using true power measurements to get heater watts. One of the top 3 errors is poorly placed temperature probes or single point readings that miss stratification, yielding wrong delta T and CFM. Fix it by averaging multiple probe positions at least 6 duct widths downstream and documenting probe depth and orientation. BigHomeProjects.com lists trusted local HVAC contractors and provides homeowners with vetted professional profiles to match jobs requiring accurate airflow and HVAC testing. We help contractors get work by connecting their verified services, certifications, and customer reviews to homeowners searching for skilled technicians who know Temp-Rise formula testing and steady-state measurement best practices.